How do I normalize and standardize data for machine learning? Imagine you're trying to teach a robot to recognize objects, but some features like size are measured in inches and others like weight in pounds. Without fixing this, the robot might get confused. That's where normalization and standardization come in. They help make all features comparable so your machine learning model can learn better. Normalization is about rescaling data to a specific range, usually between 0 and 1. Think of it like stretching a rubber, but so it fits perfectly within a box. The most common way is called Min-Max Normalization. You take each feature value, subtract the smallest value in that feature, then divide by the total range of that feature. This makes the smallest value 0 and the largest 1, with everything else proportionally in between. It's great when you know the data's bounds or when the data is evenly spread out. But watch out for outliers because they can stretch the range and skew your results. Standardization, also called z-score normalization, shifts data to have a mean of 0 and a standard deviation of 1. Imagine lining up all your data points so they're centered around 0, with most points falling within a certain distance from the center. To do this, you subtract the average value of the feature from each data point and then divide by the standard deviation. This method is helpful when your data follows a normal distribution or when outliers are present because it doesn't get affected as much by extreme values. There are other ways to normalize data too. Decimal scaling divides values by a power of 10, making numbers smaller. Logarithmic transformation applies a log function to reduce skewness, especially when large values dominate. Unit vector normalization scales entire feature vectors to have a length of 1, which is useful in text analysis. Robust scaling uses the median and interquartile range instead of mean and standard deviation, making it more resistant to outliers. Choosing between normalization and standardization depends on your data and the machine learning algorithm you plan to use. Distance-based models like k-nearest neighbors or neural networks often perform better with scaled data. If your data has many outliers, standardization or robust scaling might be better. For data with known bounds and no outliers, min-max normalization is simple and effective. In practice, you should apply these transformations to both your training and testing datasets to keep things consistent. This way, your model learns from data that's on the same scale, making training more stable and predictions more reliable. Proper data scaling helps your machine learning models perform at their best, whether you're working with images, text, or numerical data. Remember, good data preprocessing, including normalization and standardization, is a key step in building effective machine learning systems. It makes sure that no single feature dominates the learning process and that your models can learn patterns more efficiently.